We are live. Okay, September 3rd, 9/3/19. Okay, so today what we're going to talk about is what linear regression line. Okay, linear regression line and its equation. Okay, that's my hot topic for the day, huh? Linear regression line and its equation. So, the word linear means straight. Yeah, you guys started speeding up a little bit, so it's not perfectly straight, right? But it's real data. I mean, that's what I like about this thing. I mean, we didn't take these numbers out of a book, did we? This is real data, okay? So it doesn't look totally linear, but it's going to be close enough. So the first thing I'm going to do is, after I create a scatter plot, I want to then try and connect the dots. So I'm going to connect the dots the best I can. So what I'm going to do is put in what I call the line of best fit. So the line of best fit can be anywhere, but I'm going to try and just judge where it should go. So, I want to try and get my line to go through most of these points, right? We started speeding up at the end, so maybe I'll put my line right about here, okay? Doesn't matter, not yet, but I want to get the line as close to all of these points as I can, right? So I'm going to throw in a line, okay? That's my line of best fit. Is it a great line? Maybe. Will yours be better? Probably, right? Because we're just guessing where it goes. So it's my line of best fit, okay? Now, if I've got a line of best fit, what I want to do is come up with this equation. And we did a little bit of this in our warm-up, right? So the first thing I want to do is find the slope. So before I find the slope, though, I need 2 points. 2 points. So for my line of best fit, this point here looks pretty good, and maybe that point. So I just pick any two, but the two I want to pick are the ones that are probably closer to my line, right? I'm going to pick that line. Or that point. I won't pick that one. I won't pick that one because it's way off my line, right? You guys started speeding up at the end, didn't you? I mean, you guys, woo! It was really fast. But anyway, I'm going to pick any 2 points. So let's pick 2 points. Let's pick 2 points. Now I want to pick the 2 points that, and I want them kind of far apart. It makes better data. If you pick 2 points really close together, it doesn't make good results. So far apart. And then I also want to pick 2 points that are close to my line. Okay, so ones I picked were the 7. So on my chart I used the 7, 3.4. So I used my 7, 3.4. And looks like I used also my 24 and my 8.1, okay? Okay, those are the 2 points I picked, right? So let's go back to what we did in our warm-up, okay? I need first the slope. So my slope formula is y2 minus y1 over x2 minus x1. What does that mean? Well, okay, every point has some xy value, right? Every point's got some x, y value, right? And then what I have is 2 points. I've got my first point I picked and my second point, right? So if I call this my first point, and I call this my second point, right? Then that makes this my x1 value. My 7 is my x1 value. And my 3.4 is my y1 value, okay? Just because that's my first point, xy. Am I making sense? This is the second point I picked. Every point has an xy value, so this is my x2, y2. That's not squared, that's my second x value. That's not y squared, that's my second y value. I know everybody's sleepy and tired, but how am I doing, okay? So if I've got these, I'm just going to use my formula, okay? So how does my formula work? So m is equal to, let's see, my y2. My y2 is my 8.1, right? So I'm going to put my 8.1 here. Subtract y1, which is my 3.4, okay, all over. My x2, which is my 24, minus my x1, which is my 7. Okay? I've got my first point. Yep, thanks, Jay. I've got my first point, x1, y1. And I've got my second point, x2, y2, and I just plug them into the formula. Okay, so far so good. So I'm going to use my calculator. I'm just going to subtract. What is 8.1 subtract 3.4? I get an answer of 4.7 over 24 minus 7, 18, 17. Okay, and then I'm just going to go ahead and divide. I'm going to get a decimal. Nearest tenth would be helpful, so if I go 4.7 divided by 17, I get an answer about 0.27. We'll leave it, so we'll go 0.27. Okay, now that's our slope. This is how fast you were. 0.2 of a second per person. Man, you guys were flying, weren't you? But I saw the whole back row. Literally, the back row, we like almost do it all at once, right? That whole back area. So that's a pretty fast wave. It's okay though. It's fun, right? So that's our slope. 0.27 seconds per person. Okay, so that's the interpretation of my slope. Okay, that's how fast we were flying on this. Now, if we need the equation, we've got the slope, but we need the equation. So we know the equation line is y equals mx plus b, right? Now the b on here looks like about 1, but that doesn't make sense really, but we might get about 1, okay? That means if we haven't started, that means Caden's jumping up before you hit the stopwatch. Does that make sense? Which sometimes that might have happened. Maybe, right? So let's get our equation. So our equation, we're going to need our y equals mx plus b. We have an m. So we're going to use our, so for our equation, I'm going to use my y equals mx plus b, right? I know my m is 0.27, so I'll put my 0.27 in where the m is, because the m is a slope. Okay, so my slope, I figured out my slope was 0.27, so I put that right into my equation. I want to use the y equals mx plus b as my equation, 0.27 there. Now, I need a y and an x value. Well, that's easy. I can pick either 0.1 or 0.2. I need an xy value, so I can pick either 0.1. How about 0.1 because they're smaller numbers, all right? It does not matter, one or the other. Let's pick the first point, though, only because it's a small number. So I'm going to pick my first. So I've got a y value and I got an x value, okay? So the 7 is next. 7 goes there. 3.4 is a y. It goes there. So we're going to go 3.4 equals m, which I know. 0.27 times. So my x value, which is 7 plus b. So what did I do? I used my equation line. Y equals mx plus b. I put my y value of my point in for y. I put my slope in, and I put my x value of my point in for x. Okay, so far so good. And then all I have to do is just find out what x is, or what b is. So let's first, what is 0.27 times 7? I get a 1.89. So I got 3.4 equals a 1. I just multiplied those. So all I did is just multiplied that on my calculator. 89 plus b. Okay. And I'm going to solve, so I'm going to go minus 1.89. I'm running out of space, minus 1.89. So let's see, 3.4 minus 1.89. I get an answer of about 1.51. So B is about a 1.51. Okay, now let's put it all together. Let's get our equation. Our equation is going to be a y equals, our slope, 0.27 x plus a 1.51. Okay, found out what b is, 1.71, so I put that in my equation. I've got my slope. Now, the last thing I'm going to do is this. This probably has nothing to do with x's and y's. It has to do with people, right, and time, right? So I know that the number of people I can use for n, for the number of people, and I'll let this be time, and I'll go, okay, t equals 0.27. I'm going to use n for number of people, plus 1.51. Okay, there's my equation, right? Now, can the calculator do all this work? Yes. And that's what we're going to learn next, because the calculator actually can do all this, okay? So now, I'm going to go ahead and turn the page and probably turn it back, but it says, can the calculator find the equation line? Yes. It says grab a graphics calculator, which you have, right? So here's my steps, okay? And write these down, okay? We're going to do some statistics. That's what statistics is, a study of math where they take a whole bunch of big numbers and they crunch them. Okay, statistics, they take a whole bunch of big numbers and they crunch them. Like taking the average, that's statistics. That's taking a whole bunch of numbers and saying, what's the average, right? However, we're going to do statistics with this. So first of all, we're going to go ahead and turn it on. And first step is to find the stat button, okay? So you got to find the stat button, which is right there. You guys see the stat button? Okay, everybody watching? Okay, turn it on. Find the stat button. Jay, you going to find the stat button? Right there. Okay, find the stat button. So turn it on. Okay, now, edit. Edit means to make or change, and that's what we want to do is edit, because we want to put our numbers into the calculator. So the second step is to push edit. So I'm going to push enter on edit. See, it's already highlighted edit, so boom, edit. Now, I have numbers in my calculator from some other class, and I want to get rid of them. So I'm going to clear my list. So clear list. Okay, the way I clear my list is I highlight the list. Okay, so I got the list highlighted. Just move my cursor up to it. Move my cursor up, and I'm going to push the clear button and then down. Clear button clears them all. Gone. Okay, you want to try it? So go over the next list, highlight the list. The list's highlighted, right? Push clear, down arrow, gone. Now let's put some numbers in. So now the next thing we're going to do is we're going to enter data. So let's enter data. Okay, so what data am I going to put? This. Let's put this data in. So list 1, I'm just going to go, right? List 1 will go 4, 7, 10, 15, 18, 24, 27, 30. Okay, list 1, enter. Alright, so I just put in my data into list 1. And then list 2. Let's put our data into list 2, okay? Alright, so boom, 2.0. 3.4. Am I going too fast? Am I okay? 4.9, 6.2, 6.9, 8.1, 7.5, 8.6. Okay? So I got all my data in, right? Thumbs up. You guys got your data in? Now we got to do something with our data. We need to find it. We need an equation, right? So here's what we're going to do. Hit your stat button again so we get our list of things. So if I hit my stat button again, I don't want to edit because I've already edited, right? But what I want to do now is calculate an answer. I want to calculate an answer. So I move my cursor over to, so I want to calculate. So I just move my cursor over to calculate. And now what I'm looking for is the linear, L-I-N, linear regression line, because what we have is a straight line. So I want the linear regression, number 4. So we're looking for, so lin reg, it's number 4, okay, and it's got the ax plus b, all right? So it does ax plus b, which is really y equals mx plus b. They use x plus b, but we all know basically that's the same thing as y equals mx plus b. They just use a and b instead of m and b. You okay with that? Same thing, same thing. Okay, so I'm going to push enter on that, okay? So I'm going to push enter, enter. Okay. Oh, I got an old calculator. Can I borrow yours? Thank you. We don't want my old calculator. So push enter, and list 1, list 2. So go all the way down, thanks Alex, go all the way down to calculate. If you have an old calculator, then I'll have to help you with it, okay? I have an old one, okay? So go down to calculate. And then we're going to push enter. We should get our answer, okay? Am I going too fast? Okay? Okay. So are you all the way down to calculate? Anybody confused? Okay. Awesome. You're heavy. Okay, so go down to calculate, push enter. Oh, Alex, we got a problem. Okay, can I borrow yours, Alex? Austin? Okay. Okay. So here we go. So here's what we got. So A is 0.23 and B is 2. So here's our equation. They give us y equals ax plus b. So we take our 0.23 and put in for A. Does that make sense? We take our 2 and put in for B. So here's my answer. So my answer is a y equals a 0.23x plus 2. All right? We'll fix yours later, okay? So, how close was I? How close was I? Well, let me see. I had a 0.27 x plus 1.51, okay? And that's not bad, but the calculator does it better. The calculator really fits that line in. So here's what the calculator got. It got a 0.23x plus 2. Now, how good is mine? Well, there's this thing. How good of a fit? What's the correlation coefficient? Okay, now, so if we have a perfect line, perfect, 100% of the dots are on the line, perfect line, right? Then we'd have a correlation coefficient of 100, okay? So if r equals 1, it's a perfect line, okay? I'm going to show you. If r equals -1, it's a perfect down line, okay? 100% of the data, but they all match up. It's just a slope of -1, okay? If it's a 0, if r equals 0, it's like a shotgun. They're all over the place. That makes sense? No correlation. So how do we find out how good ours is? Okay. Anybody get a R factor on the calculator at all? Anybody get anything about an R? Okay, good. We're going to put it on there, okay? So let's find our R. So, okay, so let's see. To find this, so to find the R value, okay? Write this down. We're going to go into a thing called our catalog. Okay, where's the catalog? Well, it's way down by the 0, okay? Now, I don't want to go too fast, but the catalog's here in blue. It's a blue button, right? If it's a blue button, I got to push my blue button. Okay, so catalog's in blue. So push my blue button, and then I push catalog, okay? Now, what I want to do is some diagnosis. This R value tells me how good. We're going to do a diagnosis. So I'm looking for a diagnosis. So I'm going to go all the way down, alphabetical order, to D, A, B, C, D, A, B, C, C, C. Diagnosis. On. Okay, I need to turn it on. So I'm going to go all the way down to my diagnosis on. Okay, you guys see where I'm at? I'm right. So I went to my catalog and I went all the way down to here. I want to turn this button on in my calculator so it'll give me some values. Okay? So I'm going to turn it on. Enter. Okay. Now, when I go back and I do this step again, and it's on, so I won't have to do this again. Once it's on, it's on. So let me do it again. Just watch. I'm going to go to Calculate, go to Stat, Calculate, my linear regression, Enter. I get an R, don't I? This time I got an R. Same thing, I got my 0.23, I got my 2, but I get an R. So my R in this case is a 0.956. So my R value is about a 0.956, which is pretty good. It's like saying 95% of the data lies along the line. That's a good R factor. So if you get a good R, you know you've done a pretty decent line, okay? All right. Thumbs up. Did I go too fast? Okay. So let me stop the recording.